Example 16.15 is going to be our last look at a graph for a rational function. Let's start with looking at the domain. The denominator is already very nicely written out as x minus 3. So there is going to be one domain restriction on k, and that is going to be positive 3. We will write negative infinity to 3, union 3 to infinity. This is going to give us one discontinuity at 3, and I'll go ahead and tell you that the discontinuity is going to be a vertical asymptote located at x equals 3, and that would imply that there can't be any holes. All right, none for that. And this particular equation is top-heavy. When it is top-heavy, that means that there is not going to be a horizontal asymptote. But if it is top-heavy by exactly 1 degree, there will be a slant asymptote, and that's exactly what we have here. This is going to be top-heavy by exactly 1 degree. So for the slant asymptote calculation, we're going to need to invoke the division algorithm. This is going to be nice enough to allow synthetic division to work. So let's set up the synthetic division here. We're going to have 1, -4, -5 for the dividend. Bring down the lead coefficient, and then positive 3 to represent the divisor. Multiply, add, add, and the only part of this that we're really interested in is the quotient. So that means that we have a slant asymptote located at y equals x minus 1. That's your slant asymptote. The x-intercept, that calculation is done by letting k of x be equal to 0. So then you're going to say 0 equals x squared minus 4x minus 5, all divided by x minus 3. And we will multiply both sides by x minus 3, resulting in 0 equals x squared minus 4x minus 5. So if you've kept up with things throughout the semester, you have solved a quadratic equation like this at least a dozen times, if not more. This particular trinomial will factor nicely into x minus 5 times x plus 1, which would imply that x minus 5 is equal to 0, or x plus 1 is equal to 0, giving us two answers, 5 and -1. So we have one x-intercept at 5, 0, and another x-intercept at -1, 0. And then the final calculation is going to be for the y-intercept, and the y-intercept is going to be calculated as k of 0. So I have to plug in 0 for all the x's, so let's see what that looks like. 0 squared minus 4 times 0 minus 5, all divided by 0 minus 3. So then k of 0 is going to be -5 over -3, and that'll just simplify to be 5/3. So 0, 5/3 represents the y-intercept. Okay, 3 points. Let's mark those. Y-intercept. We have two x-intercepts. Vertical asymptote at x equals 3. And we don't have a horizontal asymptote, but we do have a slant asymptote at y equals x minus 1. So if you've forgotten how to graph a linear equation, you'll want to go back and look at your y equals mx plus b graphing in, I believe it was section 6, where we did that. So I'm going to come down here to -1, which is where the y-intercept is going to be, and the slope on this is just supposed to be 1. So I'm going to draw an asymptote, and notice that it's at a slant, it's at an angle, but it is going to look identical to the line y equals x minus 1. And so I'll continue to draw this as far as I can on the window. And this is going to give us the boundaries that we need for the graph. And there's only two intervals. Everything to the left of the vertical asymptote and everything to the right of the vertical asymptote. That means we're only going to need two tables. Starting with the left side, I'm going to select positive 2 as an x value, and I'm also going to select negative 5 to get an idea of where these points are located. Positive 2 is going to be 9, negative 5 is going to map to negative 5. Negative 5, negative 5, 2 comma 9, and now that gives me 4 ordered pair to the left of the vertical asymptote, and all of those ordered pair are also above the slant asymptote. We can draw a curve. Let me try that again. Draw a curve that connects all 4 of these points and then heads toward the boundaries, getting closer as you go off the window. So there's your first piece. The second piece is going to be to the right of the vertical asymptote. So this time we only have 1 point already here, but we can find a couple of more. I'm going to use 4, and let's say I also use 8. So with 4, the y value will be negative 5. 8 is going to be 27/5, which is equivalent to 5 and 2/5. So let's mark those: 4, negative 5, and then 8 and 5 and 2/5. So all 3 of these points are to the right of the vertical asymptote, but also all 3 of the points are below the slant asymptote, and I can really see a curve here. So I'll connect them with a nice smooth curve, staying within my 2 boundaries here, and then all of this together gives me the graph of K.